In this video, we're going to discuss two types of errors you can make when you're performing hypothesis tests involving individual intercept and slope coefficients in the bivariate regression model. In hypothesis tests, there's two possible types of errors you might make, and we call them type 1 and type 2 errors. For a hypothesis test, there's four possible outcomes. One is that you reject a null hypothesis, which is false. That's not an error. That's what you would want to do. If it's false, you want to be able to reject it. However, if you reject the null hypothesis when it's true, that's what we call a type 1 error. So a type 1 error is rejecting a true null hypothesis. You could also perhaps fail to reject a null hypothesis that's false. That's what we call a type 2 error. And the last possible case is that you fail to reject a true null hypothesis. And in that case, if the null hypothesis is true, you don't want to reject it. So the first and last of these are not errors. That's exactly how you want things to happen. But there's two types of mistakes you can make. One is if there really is no effect, if the null hypothesis is correct, but you reject it, finding evidence of some effect, that's a type 1 error. If, on the other hand, the null hypothesis is false and there really is an effect, then if you fail to reject the null hypothesis, then you've committed a type 2 error. The basic point, and I've already suggested this a bit, is that the burden of proof is on the researcher. And as I've noted, the null hypothesis is stated as the opposite of what the researcher's model predicts. And it's very similar to the criminal justice system, or at least the criminal justice system as it exists in theory. The basic principle of jurisprudence in the US, at least in principle, is that the person is innocent until proven guilty. So the null hypothesis is that the person is innocent. And the burden of proof is on the prosecutor to provide compelling evidence that the person is not innocent. Let's think about what the type 1 and type 2 errors are here. If the person is really not guilty, but you convict them, think about what type of error that would be. I think that would be a type 1 error. Alternatively, if you fail to convict someone who's guilty, that would be a type 2 error. So there's two types of mistakes you can make. One is you might fail to convict someone who is guilty, or you might convict someone that is innocent. But in either case, the burden of proof in theory should be on the prosecutor, and that's what the legal system is designed to try to do. In the criminal justice system, when there's criminal activities, the probability of a type 1 error is set to be very low. And the usual standard is that the prosecution has to provide proof beyond a reasonable doubt or proof beyond a shadow of a doubt. So you want really compelling evidence before someone is found guilty. You don't want to commit very many type 1 errors. And there's a classic quote from a judge whose name I forget actually, that it's better to allow 1,000 guilty people to go free than to convict one innocent person. In practice, it doesn't always work at that sort of ratio, but that's at least the stated goal, that you want to provide really compelling evidence so that you don't take away the liberty of someone, or in the case of capital offenses, their life, unless you have overwhelming evidence that they really are guilty. And similarly, you'd like to have people being punished for their crimes, but we don't want to do that at the expense of a high level of type 1 errors. We're going to use these concepts throughout the rest of the course. We define the probability of a type 1 error as the significance level of the test, also known as the alpha level. The confidence level for a test is a probability of avoiding a type 1 error. And since we know those two things are mutually exclusive alternatives that are collectively exhaustive, the probability of that is 1 minus alpha. In other words, if there's a 5% chance of committing a type 1 error, of finding that something really has an effect when it has no effect, then the probability of avoiding a type 1 error would be 95%. The probability of avoiding a type 2 error is called the power of a test, and that's usually written, I believe, as beta. We're not going to do as much with power in this class. In general, we set the significance level, or the alpha level, at a level that appropriately balances the costs of type 1 and type 2 errors. Because if you set a really high standard of proof, you're not going to have very many type 1 errors, but you're going to have a lot of type 2 errors. In other words, if you require, for example, in a criminal justice system, overwhelming evidence of guilt, some guilty people are going to go free, but very few innocent people will be convicted. On the other hand, if we set a lower standard of evidence, then what happens is we convict a lot more guilty people, but more innocent people will be convicted as well. Now, in theory, we should set this so that they balance the costs of these errors, because each type of error has a cost, and that really is going to be different depending on what you're discussing. In terms of, let's say, the legal system, we set a really low alpha level, which means the probability of a type 2 error is relatively high. However, in civil trials, what's true about the level of evidence required? In civil cases, what matters is the preponderance of evidence. So you can convict someone of a civil offense if there is more evidence supporting that they're guilty than there is evidence suggesting they're not guilty. So in that case, you have a relatively high probability of a type 1 error. And the reason is, following this principle, in the case of criminal trials, you could end up in jail. You could end up losing your life in the case of capital offenses in many states. So the cost of making a mistake and convicting innocent people is really high. In civil trials, only money generally or property is at stake. And therefore, the cost of a type 1 error, while it's non-trivial for the people involved, is much lower. And again, the trade-off is that when you set a really high standard of proof by setting a low significance level, the probability of a type 2 error rises. In practice, significance levels are usually set at 10, 5, or the 1% significance levels. So you'll see on many papers, it'll say alpha equals 0.1 or alpha equals 0.5 or alpha equals 0.01. And what that's saying is that's the standard of evidence that you're requiring, which is a probability of finding that something has a significant effect when the true value is 0. And the reason we tend to go with these 10, 5, and 1% significance levels as the standards of proof is because if we let researchers set the standard, they'd always have an incentive to adjust the standard based on the results they find. So by agreeing to these, where we might say 10% is weakly significant, 5% is significant is how people often phrase this, and 1% is a result which is highly significant, those are the types of words that researchers generally use to describe the significance of results.